Hello, guys. Welcome to the seventh episode of this series, Programming with Solidity. During our last session, we look at the first smart contract that we built together. So, in this episode, we are going to look at data types and the various data types that we have in Solidity. Now, data types are super essential in every programming language because we use it to make calculations. Now, Solidity is a statically typed language, which means that the type of variable should be specified, right? Whenever you are defining a variable, you should specify the kind of data type you want to use. There are two main type of data type in Solidity, and we have the value data type and also the reference data type. Now, with the value data type, we have boolean, we have integers, bytes and strings, enums, we have fixed point numbers and address. All these belongs to the value data type. Then also we have reference data type, which include arrays, struct, mapping, right? So let's get our hands dirty. I will clear all these stuffs here, right? So we are going to create a new smart contract, right? So remember, in order to for us to begin, we have to define the contract like this. So contract, then we give it a name. We call it types. Data types. Then we put everything inside this um, curly bracket. Now, the first data type we are going to look at is boolean, right? So call it boolean data type. Now, Boolean data type can have only two states. It's either true or false, right? And by default, they are false in Solidity. So, in order to do that, we could say bool, right? So, bool public. Then we say, let's say hello. Now, we are using public because we want to get the value of it. Then, um, if I have another variable, I could say bool, right? Public. Then I'll assign this to a variable. So I'll call it, let's say number, right? Equal to number equal to true. Okay, semicolon. Now, if I compile this, auto compile is there. So if I compile this and run um this particular code, the smart contract here, make sure you are on the appropriate environment. So once I click on deploy, I have my contract here. So I have hello. So you see, we didn't assign anything to this particular uh, boolean variable, right? So when I click on hello, I have false, right? Likewise, when I click on number, I'm supposed to get true because I've assigned it to the value true. So by default, the boolean itself is false, okay, unless you force it to be true. So that's how boolean works. So you need to take account of it. Now, the next thing we are going to look at is the uint, right? The uint. Now, uint is it stands for unassigned integer, meaning that you cannot assign a negative value to it. It can only accept positive numbers. Now, this part is super important. Pay attention because most of the calculation that we are going to do, we use this. Now, aside uint being a particular type of data type, we have various types of uint, right? For example, we have uint. Okay, so uint 8. Sorry, uint 8, right? As this. Sorry, uint 8. Okay, then let's call it it's supposed to be public, so that we have, let's say, uint 8 this way, right? Good. Then we can have uint, sorry, uint then 256. There is 16 also, so let's go into this order. So we have U16, then we have U int 256, right? Then we have it as public. Then we call it U 256, right? Now I'll comment these guys out, right? So that I will save it. Then once I deploy, take this guy out. So I have um, uint16, uint 256, and uint8. So when I call uint16, I have 0, this guy to 0, this guy to. So by default, they are what? 0. Now, what you have to understand is that all of these things, they have ranges. So for example, this uint 8, so it ranges, right? It ranges from 0, okay, 0. So let's say, in order to get it, so 0, from 0 to, 2 times 8, right? So this is the range that you could get, and minus 1. So it's going to give us something like 255, right? Minus 1. Okay, 255. Now, if we do the same thing to the uint16, when you calculate it, you are supposed to get something like, let's say, 655 something. 655 something. Then, if you do this one also, we could get to a very large number, right? Very large. So all of them, they have ranges, and you need to know the ranges in order not to waste, gas. If you don't know these ranges, it can cause a lot of uh, calculation error in future, right? So it's like 1 5 something something, very very large complex number, right? So all of them, they have a range that they go around, right? Good. So I'm going to assign these guys to a value. So let's say this to 4, then this guy to, let's say, 15, then this guy to 54, something like this, right? So if I save this, since I've clicked on auto compile, once I can also compile, no, it's no harm. Then once I deploy, I'll have these guys as this. So 16 is 15. Since we assign 15 here, we have 25 to 54. Then this guy to be 4, right? Now let's try to assign negative to it. Let's see. Now we have an error here, right? It says that type int constant -4 is not implicitly convertible expected to add. So meaning we cannot add negative values to uint. So the next data type we look is what? Negative integers, the one that can accept negative integers. So let's say negative integers, right? Good. Now, in order for us to do that, it goes the same way as one we have, right? So we say int instead of uint, we say int. So we say int8 public, then u8 equal to -4, right? All right. So I've already declared it here. So I'll comment these guys out here, right? Then I have int again, int 16 public, then u16 is equal to -15. Sorry, -15. Then I have int again, then 256. Then we have public u256 minus is equal to -54, like this. Okay. Now these also have ranges, okay, and they follow the same order but in a negative pattern, and by default they are 0. All right. So if I deploy this contract, let me delete this guy. Then let me run the contract again. Right? Good. So uint have minus 15, minus 54, then minus 4. Right? Good. So that is on that's assigned. Negative integers. Right? Now, one thing you could do is that we could find the minimum. Right? We could find the minimum and the max, right, of a particular um, data type. So, for example, I could have let's say int 8, right? Then it will be public. Then I'll call it minimum integer, right? Then equal to type. It's a type of function, right? Good. So type. Then I will put um, int there, right? Sorry, int 8 over there. Then I'll have a method of dot mean. Okay, a method of dot mean. So I have something like this. Now, first of all, I need to comment these guys out, right? So if I deploy, need to delete this. So I will do so mint int. I have minus 128. So that's the minimum. Then I can have int um 8 again, right? Then public, then max int, right, equal to type, not type of, so type of int 8 again. Sorry, int 8, then dot max, then have a semicolon. Sorry, there's no bracket there. Alright, so once I deploy, let me get rid of this guy. So once I deploy, I could check. So have min int as, so the maximum is 127 and the minimum is minus 128. Now, sometimes you want to avoid certain scenarios where transaction can be gas fee can be wasted. So you could use these approaches to suppress such scenarios to happen. So all of them we can find the minimum and the maximum of each one of them. Now we can also look at another data type called array and byte. Now there is no so much difference between arrays and byte. So let me comment these guys out. So I have arrays like this. Now, like I said, there's no difference between byte and array, but then byte is more gas efficient when it comes to array. And if you have a choice to use string and byte, we are talking about string and byte, which belongs to arrays. So they are not so different. That is strings and byte, but byte is more gas efficient. So if you have a choice to use a string and a byte, you should go with the byte because it will save you gas fee at the time of deployment, right? So with that too, we have um, fixed array and dynamic array. So the fixed array is the one we create and give it a limit, but with the dynamically, it means that the size of it can increase. So for example, we can have a byte 1, right? We can have byte 1, then we can make it public, right? Then we call it A. Now let's see how it will be printed. Then we can have byte 1 again, then it will be public. Then we call it B. Now let's see the value, by default value of this byte. So I will delete this deployment, deploy it again. Then once I open it, when I click on A, you see the value it is giving me 0000 in a certain number, right? So we have the same thing over here. Good. So what I could do is I could assign this to, let's say, um 0x b5, right? Then I could give this guy to equal to 0x56, like this. Now I will delete this deployment, deploy it again. Then once I open it, have it this way, then this that way. Now this one, in computer science, is the convention. You could have something like, you could have like, computer does not understand um, high level language, right? So we have to translate it to the machine language. So you can have something like 101100101, something like this. Then we can also have this guy to be, let's say, 01010110, something, like this, right? Good. So these are the data types that we are going to look at, but we have each one for a whole video upcoming. So this is how I'll end um, data types, right? And we are going to apply them in almost whatever we are going to do. All right. So before we end, I will get the default for each one of them, right? So let's say I will say that. So I'll give a comment and say default data types for you to understand. So data type that have not been assigned, right? Each one of them, the one we've treated so far, that are not been assigned yet, what are their values? So for example, if I pick boolean, then it's public, right? Then I'll call it, let's say, default bool, right? Equal to, sorry, default bool, like this. We will not assign it to anything. Then I have the next one is uint, right? By default, so public. Then I'll call it number, right? Then I have the third one, which is int, then public. Then I'll call it default int. I'll not assign it to anything. Then I have yes, I have address. I didn't talk about address. I'll do before we go. So public, right? Then I'll call ADR, like this. All right. So if I save this, then I deploy this contract. Let me delete this guy. Deploy it again. Right. So I have address. So once I click on address, it will be 000. Then default is false. Default of this is 0. Default of this 2 is 0. Now, what is an address? Now, if you go here, we have account. So this is our address. Now, remember when we're talking about types of account. Now, you need address to send ether to a different person. It's like that's our wallet. We take the address, identify who we are. Okay, good. So in order for us to know our address, so we will need it. Sometimes we write a smart contract to automatically send a particular ether to a different account. So in order to get the user address, you have to use this address, right? Good. Now, I can copy this address here. Then I will comment these guys out. Then I will say that address, right, ADR equal to, sorry, public. It should be public ADR equal to. Now it's a Solidity syntax. It's a literal, right? So I don't need to put it in a double quote or any single quote, right? Once I put it this way, once I deploy, it's over here. I could get it by clicking on address. I can have it here. But by default, right? By default, if I clear this smart contract, clear this guy, then deploy it again. By default, it's what 0000. All right. So thanks for staying tuned with us. And expect the next video very soon. Thanks for watching, and don't forget to subscribe and share.